Saxon Advanced Mathematics, Lesson 21. We are going to talk about two special trig triangles. We talked about these last year and used them quite a bit, so we're throwing back to that, and we're going to practice developing them so that you can figure out what you need to memorize and what you can reproduce, and then we'll use them. The first one is called the 45-45-90 triangle. I think this is the easier of the two to think about, and it works. You can draw it either way. I usually draw it facing this way, but you can draw it the other way too. What we need here is a triangle that has equal angles in those corners, roughly. It doesn't have to be perfect. There's a 90-degree angle, and then what we're saying is that these are 45-degree angles. Now, when we work trig equations, we have got the ratios of the sides for any angle you can think of programmed into our calculators. Back in the day when I was in high school and college, we did our calculators, we had them, but they weren't that smart. So we had tables in the back of our books where we had to look all this stuff up. It was a life. And the trig triangles were even more precious to us back in those days. Because when you're using a special trig triangle and you're using one of these angles, in this case it's just 45, but we have the other triangle to consider, you don't have to use your calculator or the angles because we already know what the ratio of these sides are going to be. And here's the way we remember for this one. We take these legs and we're going to make each of them 1. That's easy to remember, right? They're basic. Now we mentally apply the Pythagorean theorem to solve for this. A squared plus B squared equals C squared. I'm not even going to write this down. We can do it in our heads. So we square this, we square this. That's 1 and 1, right? 1 squared is 1, 1 squared is 1. We add them together, we get 2. That's C squared. So now we need the square root of that to be C. So this side is square root of 2. Again, here's how I did it. We assigned those ones arbitrarily, but that's pretty logical, right? 1 squared is 1. 1 squared is 1. Those add together. And then we take the square root, so then we can say C equals the square root of 2. And that's what I wrote right there. Notice we do not need the negative root because I'm pretty sure that's not a negative length, right? So if we memorize this, then anytime we're trying to figure out the sine, cosine, or tangent of a 45-degree angle, we can build it out of these side lengths. And we're going to do that in just a minute. Actually, you know what? Let's do it right now so that we get practice on it before we throw the other kind in here. We want to do 20.2. That relates to this kind of triangle. It says, draw the necessary reference triangle and evaluate sine, 7 times the sine of 45 degrees. Well, that looks like something we'd plug into the calculator, right? 7, that would be the hypotenuse of something, right? We're trying to find the side. But we don't need the calculator for us. That's the magic, right? Now, what we do need to remember is which sides form sine. Oscar had, right? So what we need to do is we need to, I'm going to pretend that isn't right there. Sometimes it is helpful to draw this triangle like this because we're used to standing here in our reference triangles, right? So I'm going to draw it reversed. It's not a very good 45-degree triangle. I'm sorry. This one's much better. But I don't even have to look at that. I remember give the legs 1, and then I can mentally do the calculation, or even on the paper if I need to, but I've memorized that square root of 2. Sine is opposite over hypotenuse. So to do this calculation, I'm going to multiply 7 times opposite is 1, hypotenuse is square root of 2. right? Because this is this. I built the ratio out of the sides. I do not need my calculator. Now all I need to do is multiply it through, and I get, because this is 7 over 1, right? We can do that whole fraction thing. This is 7 over the square root of 2. Sirens and alarm bells go off because as mathematicians, we cannot live with irrational numbers in our denominators. So we rationalize it, which is easy to do because we just multiply it top and bottom by whatever that is, because these two pigs will hop together out. And so this becomes 7 square root of 2 over 2. That's the right answer. Now, some students look at that and go, that's not what an answer looks like when it comes out of my calculator. If I would have punched this in, I don't think I'd get that. I'd get a nice little decimal number. That's true, because this is an irrational number. But we can take, number 1, John's going to be perfectly happy with this as an answer, right? You don't have to generate the decimal number. This is good. But if we wanted to generate the decimal number, we could just put a 2 into the calculator, hit the square root sign, then multiply it by 7, divide by 2. So we can get the decimal number if we need to. But this is the answer that John will accept. All right, let me just double check and make sure. Here's another one. Example 20.4. I'm doing all the examples that relate to this triangle before we go on to the other one. Draw the necessary reference triangle and evaluate 10 over the square root of 5 times the tangent of 45 degrees. Okay, now let's just pretend that we don't have those in front of us. And I'm going to draw the triangle again. And again, I'll draw it this way so that we're here oriented by one of the corners. But either way works. By the way, I wanted to say this. Like any formulas, or these reference triangles are another good example, if you've already written it out once on that page of homework, you can use it again. But then if you turn the page and you're starting a new problem and you don't have that reference triangle right in front of you, I want you to draw it over again. It's a great way to practice, and having it in front of you makes it a lot easier. I've drawn it. I'm going to be drawing it 3 times on the same paper. It's not necessary for you to do that. That's kind of overkill, but at least once. Okay, so it's 45, 45. I give the legs 1, and this becomes square root of 2. Okay, this is what I'm multiplying against it. That I don't have to change. The tangent of 45. Okay, I jot over here. Tangent is Oscar had a hold over Arthur. So from here, I want the opposite side. I'm multiplying here. 1 is the opposite over the adjacent. Also 1. Oh, it's pretty easy, right? So now I multiply through, and I get my answer is 10 over square root of 5. Bells and whistles, that can't be. Alarm bells and whistles, right? I need to rationalize my denominator, have to do the top by the same thing, and I get 10 times the square root of 5 over 5. And then last step, I can cancel those. My final answer is 2 square root of 5. Did I get it right? Yes. Okay? So remember to rationalize that denominator. And since our hypotenuse is irrational, and 2 of our trig functions call for hypotenuse to be on the bottom, right? Sine and cosine would both have that on the bottom. We get a lot of denominators in these problems that need to be rationalized. So keep an eye out for that. And remember, if we see pig houses in the denominators, we freak out and we have to fix it, which is easy, right? Okay, so that is our practice on the 45-45 triangle. And now we flip and we're going to do the other one. As you remember, the other one's a little bit more complicated, but if you learn to develop it in the way I'm going to show you, I think it helps so much in helping you memorize it. The first thing I'm going to do is I'm going to draw an equilateral triangle as best I can, pointing to the left. Okay, I can do that. And then in the last one, we made the legs 1 unit each. In these, I'm gonna make all of these 2. Not 1, but 2. The 45 degree triangle we did first, so it gets the 1s. This one we did second, so it gets the 2s. Now, and I'm gonna write 60 degrees in each of these corners because it's equilateral and equiangular, right? The sides are all the same, the angles are all the same. Now I'm gonna do something a little crazy. I'm gonna chop it in half. And I'm gonna redraw the parts that I want in blue. We're ignoring the bottom half now, and we're only looking at this. This side is still 2, isn't it? That's great. This is still a 60-degree angle, isn't it? That's great. This side that used to be 2, I cut it in half, so this is now just 1. Huh. This angle I cut in half, it used to be 60, now it's 30. I'm just gonna smudge that out so we don't get confused. This angle is a 90-degree angle. Whoa. Just by chopping this in half, we've developed 5 of the 6 pieces of information for this triangle that we want. The only thing we're missing is this side. But again, we can use Pythagorean. I'll just use this color. Okay, this is one of the legs. This is the other leg that we don't know. And this is the hypotenuse. 1 plus b squared equals 4. We subtract 1. B squared equals 3. So b equals the square root of 3. Now, that's kind of random, but if you remember that we have a 1 and a 2, if you can get the 1 and the 2, just remember it's not 3, but it's square root of 3. 1, 2, 3. It's so nice, right? This one was 1, 1 and square root of 2. This one is 1, 2 square root of 3. That's a satisfying little pattern, isn't it? So now, without drawing the bottom half, we can practice this. And I always draw them oriented this way because it helps me imagine the bottom part. Here's our right angle. This was our original one that stayed the same. This is the one that got chopped. This is the original length that was 2. This was the side that got chopped. 1, 2, square root of 3. There it is. Yay! It's so cute, right? So this is what we call our 30, 60, 90 triangle, and we use it just in the very same way that we did the 45. The only difference is, and the same thing, right, where we've got the sides, we can create our own ratios. We can skip using our calculators because we don't need them. We're going to get numbers that have radical signs in them quite often, but that's okay. We're fine with that. The only thing that's tricky about this is that if we have 30-degree angles, we orient ourselves this way. But sometimes we're using 60-degree angles, so we have to orient ourselves as being up here. And so what is quote-unquote opposite and what is quote-unquote adjacent will change depending on which angle we're interested in. The hypotenuse, of course, always stays the same, but these side lengths, we have to just keep our heads on straight when we're doing these problems. All right, hey, let's do a problem. We only have 2. 20.1 relates to this size. It says, draw the necessary reference triangle and evaluate tangent of 30 degrees. Okay, I'm not gonna draw it again because I just did it. But first I remind myself, what the heck is tangent? Oscar had a hold over Arthur. 30 degrees means I am standing here, so this is me. So the tangent of 30 degrees, I'll just squeeze it in right here. The opposite side is 1. The adjacent side is square root of 3. Ding, ding, ding. We better fix that. So my final answer is square root of 3 over 3. That's what the tangent of 30 is equal to. Yay. Did I put smileys on my other ones? Yes. Okay. Thank heavens, because you know what? It's not officially a math lesson if I haven't put smileys by my answer, for heaven's sake. Okay, we did 20.2. That was one relating to the other triangle. Now we have 20.3. Draw the necessary reference triangle and evaluate 4 times the square root of 3 times the cosine of 60 degrees. Okay, so this time we're up here. Notice I don't redraw the triangle to put the 60-degree one down here. That's too confusing to me. I just reorient myself and say, okay, I'm up here on the mountaintop or floating in midair, whichever you prefer. My reference, my perspective has shifted to up here. Cosine is Oscar had A hold. So this is this one. So I know that I need to use, it's 4 times the square root of 3 times the adjacent side to me here is 1, and the hypotenuse is 2. All right, so this is over 1 when I multiply them. I'm going to cancel the 2 against the 4, and so my final answer is 2 square root of 3. Radical signs in the numerator are 100% great. It's just the denominator that frees us up. Okay, so once you get these reference triangles in your head, it's a very simple thing to just pick the lengths of the sides that fit the trig function you're working with and then simplify the algebra. Guess what? You have now completed lesson 20 and it didn't take us, seriously, an hour. I'm so excited. That was fun. I'm done with you now. Thank you. Goodbye. I'll talk to you soon.